Okay, welcome back. I've got another series of little vignettes, demos, and essentially practices that I've been messing around with. In this case, we're going to look at some surfacing examples. There's a number of them that I can just rip through. So sit back and relax and watch this section. This first one actually came via the forums, and somebody was asking a question about why this surface wasn't offsetting very nicely, and I'm not sure how well it will come through on your screens, whatever you're looking at it on, but there's already some telltale signs of bad surface quality in here. And before banging your head against a brick wall trying to force shells or thicken or other offsetting and Boolean types of operations to work, it's always good to go back to the root cause and look at why things are the way they are. So the first thing I would do is pick one of these faces and then run a curvature analysis of the surface. And you already see lots of weeble wobbles across it. That is looking fairly ugly. If we look at the U-curves, it's even worse, especially near where it gets to this bit here. So I turn off the control point grid just so that you can focus on that. And you can almost lose an eye, injuring yourself looking at these curvature combs, so better tone them down a bit. But even so, that isn't going to bode well for any type of operation that uses this surface. So the question is, why is that? And it almost invariably, pretty much invariably, the answer is let's look at the curves that create that face to start with. Now I must say that also this is an imported body. It came in from import from somewhere. There's actually 3 for each of these. So there's one there, and one there, and each of the quadrants are like that. You see it's going to repeat itself around like that for the rest of this. That's a pretty bad sign. So let's look at those edges individually and then run the curvature analysis on that as well. If we look at the curvature combs here, nothing too much to see. Although if you look at the opposite side, and there is a gap, so they're not tangent. They're not tangent there. That's a pretty bad sign. So the next curve along in this chain is not great either. And if we look around it, there's a big wobble in there, and you'll see that it actually comes kind of out of plane. If you look down that curve, the wobble isn't just in one direction, it's actually in this other direction too. The real problem is the next one here, and you see that this edge is just full of noise. Not sure how this happened. I won't speculate too much other than to say that you don't want to see curves with this diagnostic. And if you do, then it's best to rethink what you're going to do with it and perhaps do it again from scratch. This is not a terribly difficult surface model to potentially just redo from scratch, which is kind of what I did over here. And let me roll it back a little bit. You see that it started out with a circular profile, and we're looking at it from the front. This is the view that we would be trying to achieve here. So if we think about it in this one quadrant, there's a line which really should be tangent here in that direction, so in the x direction, starting from this point going in negative x. And there's one that should be going in negative z from this point here. So we could use that, and then we can see that this one curve is actually going to connect tangent there, roll around and go tangent up the top. So what it did was set up 2 little segments, one of them in x and one of them in z direction. And then I use my favorite feature, which is a bridging curve. A bridging curve is available in the tool set up here, halfway down, bridging curve, or you could do what I do, which is put it on a shortcut in the shortcut toolbar. So it's one S key stroke away. I'm going to choose tangent, tangent, so tangent and tangent in this case. We're going to use this curve and this curve. not that point, but the curve. And we're going to provide an additional vertex for each end so that we know exactly where it's going to come off at the end there. So in fact, that's the bulk of that shape already. It's just a matter of tweaking the control points. So you can edit the control points, and then you get these here, so that you could, as an additional guide for editing these control points, you can put curvature combs on. And you notice when you hit Shift C now, when you've got something like this, when you're creating a feature like this, there's always this extra option up the top saying previewed edges and faces. So it's selecting that automatically to provide where the curvature combs would be. So you can see here these combs are very, very smooth, and we didn't have that in the previous example. So we can either eyeball that now, or we can finish creating the loft. In this case, I'm going to use a loft. I provided one more curve, which is that guide, which is from the top view, kind of like this top view here. It's this guide curve there. So I created that curve. Now I've got enough curves. This is going to be my profile and profile to loft, and this is going to be the guide curve. And that gives me a loft that looks a lot like that. We can pick the curvature analysis again, and now you can see, in contrast to that thing we saw first, this is much, much smoother, and we're going to have a lot more success downstream. So I've finished this off with a mirror and a mirror, and with this mirror I'm using an add, which will automatically do the merge with all. And those of you that haven't tried that before, rather than having to do a separate feature to boolean them or knit them together afterwards, you can, in Onshape, you can just do an add like that, which leaves us with a single surface, and then we mirror that whole thing again using the same add technique when we finally have this. So once we have this, we can do our zebra analysis, or zebra analysis if you're from where I'm from, and a color map on this as well. Now the color map is going to be nice and smooth. You're looking for smooth gradations through the spectrum. You don't want jumps or wobbles. You're going from back and forward, generally speaking. This is a Gaussian curvature, so anything negative is going to be a saddle shape, and there's a very, very clear saddle in there in the green section. But in fact, all of this is pretty much below zero in a very slight amount. So that looks nice. In contrast to the Gaussian curvature plot we would have for this one, which if we look, it actually takes a little bit longer to compute because there's so much noise going on in the surface. You can see how wobbly this is. You can see these hot spots that go back and forward between hot spots and not hot spots. Again, you do not want things looking like this in the when you're doing a surface curvature analysis. You much more want to see something like that. All right, so that's the first example. I'm going to roll this one back to show you a couple of things. This is a few surfaces that I've picked. There was another one here which I've deleted because that was from a different demo somewhere else. But here I just want to make a smooth blend between all of these three. Kind of a T-shape, but it's not planar, and these aren't planar themselves. So again, the bridging curve is going to be the answer to everything here. So just rather than roll through it, I'll do some of the features from scratch. So I want to do a curvature bridging curve in this case, and I'll choose the vertex and edge, giving a nice curve in there. Now I can pull the control points further to adjust the strength of the curvature. I can have a look at that. You can see that the the curvature in here is very good. I can add this face and you can see how that curvature is mapping exactly to the one next to it. So we've got a nice G2 connection on both sides, because that's what we asked for. So good. We do the same thing over here. We can choose this vertex and this edge, and then this vertex and this edge. We have a nice G2, it's a degree 5 spline there as well. Now where it gets a little bit more interesting is around this section here. So I'm going to do a curve from here to here, and you see this one, if I turn the control points off, you know, it's a non-planar, it's a 3D spline in there. Again, curvature continuous to what is next to it, like that. The final curve, oh no, there's two more final curves. There's this one here as well, it's very similar to what we've just been doing. So that one again. Now this one here, I might want to control a little bit with the control points. It seems to be a little bit either aggressive, or so I can bring this down, and we can play with that once the surface is in. But I'm just tweaking the control points using these. You know, I can type in a value if I really want to, if I want to keep it even. But usually it's by eye, right? These are remaining curvature continuous, there's no problem with that. Now the interesting one is going to be from here. I'm going to choose this curve here and this vertex on it. But then on the other end, I'm going to use this whole edge and this face to define where I want the curve to go. Now I can just drag this along, until I get it approximately into the right place, like that. And I can even adjust the tangency angle, or the angle that this comes off. Now this curve, if I do that at maybe 10 degrees is close enough. This curve is curvature continuous to that one, to that edge. That face, sorry. You know, there's a measure tool that we can use already. There's a few different measure tools we can use. I'm not sure if anyone's seen this before, but in Onshape, when you select an entity, you already get an instant feedback on some property of that. In this case, the obvious one is length, but if I choose the measuring details, there's a few more things that you can do, especially depending on what you've picked. So it might be a minimum distance here, or a maximum distance, or the length total of all the entities we've picked. An interesting measurement you can do is one edge and one face, and it will tell you what is the tangent angle between those. Like, does this edge meet this face at a tangent angle of 0.0000? So that's what we've done there. It doesn't actually tell you curvature. To do curvature, you're going to have to use that kind of a check. And we don't have a face here, we've just got a curve at this moment. Actually, while we're here, if I put that curvature back on, you can see that this is slightly, there's a bit of torsion or twist. If you see, the combs aren't all coming out in the same plane. And if there are reasons why you don't want that, and there definitely might be, you can go back and edit that curve, turn the curvature combs on while you're in editing mode. That's something that you can do. And if you see that as I change some of these dragging around like this, it really exacerbates the torsion. But if I come back to closer to a 0, or actually 0, maybe closer to 0, around -2.5, I flattened that out a bit. So that is an additional control that you might want to experiment with. Now I'll do one more of these tricks on this side. Use that edge and that face, bring the line back, turn on the curvature to try and get rid of that torsion, line it up in the view like this. We're always adding new diagnostics and working on new diagnostics. That's something that we've been doing and expanding on in the last number of releases. So yeah, expect some additional things in there. So now we can use our favorite surfacing techniques to finish this off, whether it's loft or boundary surface. In these days, we've got this new boundary surface feature, which will allow us to do this in a very nice way. I'm going to choose tangent C on both of the ends there, so we've got a nice face there. And again, as soon as we do a face, we should be evaluating curvature like this, and maybe looking at control points. And you can see here the control points are nicely spread out. 1, 2, 3, 4, 5, degree 5 along here, because that's the guide curve we gave it, was a degree 5 spline. So that was what we wanted and what we expected there. A couple more of these. Maybe I'll go from this one to this one, and then see how it's automatically put the surface all the way along the edge, but by limiting it to these V profiles on those curves that we defined before, then we can make that a smaller surface. I'm going to make that match tangent across here. Do the same thing one more time. Match that tangent. Match that tangent. Now this menu does get long. There's a lot of options perhaps when you've selected faces. So it's best to collapse it down to let you focus on here. So I'm going to use these guide curves that we defined before and have a nice one in there. I'm going to switch all the curves off, just leaving the edges of the boundary surfaces that we created from before, and do one final boundary surface, which is going to be defined by this direction. It's gone red because it doesn't know how to attach until we give it the other direction as well, like that. And I'm going to ask it to be match tangent across all of those. So again, collapse it so that we can keep the view onto that nicely. Now you can see a really nice reflection line already through here. If we look at the curvature plot of that thing that we put in, it's very, very nice. It doesn't have those ugly spikes anywhere. And then, we might use other tools such as the zebra stripes to assess our work and see if we need to go back and do any other tweaks. Now, the tweaking can, of course, happen if we go back to... Oh no, we'll leave it in this view. I'll hit Shift R to get my high quality view. It just sort of, with a model this simple, it doesn't really make too much difference. I'm going to pick one of those boundary curves, maybe the one that we did just there. If I edit this one and hit the final button, you'll even see all of those diagnostics that we've been requesting. Like that one there. I've got diagnostics on the curve we're creating and on the face, but the face is a little bit too distracting. I can drag this and have the zebra stripes update in real time, and if there's a particular effect I'm going for, then maybe there's a reason that I can keep tweaking this around like that. Go back to the shaded view, and you can see that's a nice... I was looking for a particular highlight that flows from this left here and kind of down this major ridge line here. If I wanted something slightly different, then I'd get rid of that little dimple in there and perhaps try and flow it more naturally across the top here. Anyway, there's a lot of options, and this is just one example there. All right, the final little demo on this section here is a really simple one. It's a new feature we added called mutual trim. I've got these two bodies, the two surfaces. We're in a part studio in Onshape, which means multi-part studio. We can deal with multi-parts simultaneously, but of course, we can Boolean, we can merge, we can trim, we can intersect, And now there's an option to do mutual trim, which means I choose two surface bodies like this, or sheet bodies. And it's showing me, if I use that full preview, it's showing me what's left. Now it's also giving me these manipulators to change the side of what I want to keep versus what I want to throw away. And in fact, this is what I want to keep, like that, and it's going to automatically merge them into one, or else I could not merge them. I could leave them as two separate bodies. But in this case, merging them into one sounds good, like a good idea. And then perhaps I would do something like put a fillet, an edge fillet on this one. And maybe we want to make it a curvature continuous edge fillet of radius 7 or distance 7 there. That's all good, and it gives us a nice thing. But if I delete that, and I actually have a new way to do this, and that's with a face blend. A face blend is not a fillet, it's a blend, and it can operate between separate bodies and separate surfaces in this case. So I just do a face blend, and side 1 can be this, side 2 can be any face on here. And you see, in one shot, it's actually given me the equivalent of doing those two things before, the mutual trim plus the edge blend. So in this case, the face blend has done all of that for me, and I can, and I've got a lot of options to play with in here. I could go back to the, what was it, 6 or 7 7mm curvature continuous blend between these two surfaces. And just to show you a couple other things, I could actually ask it to remain detached, which means the blue face is what I created, but it's not going to trim any of the thing, or it's not going to get rid of the intersect with the original faces. So that can be handy because I can keep those and I keep that and do something else with it. Maybe I'm going to do some more construction, build something else out from it. That's a handy thing. But if I do want to try and trim it all up, I can use that. Don't use the detached option. I'll show the ISO lines on here. That's always a good time. And then that's pretty much what we would like to do with here. Oh, just one other thing on this. Of course, we can do a circular fillet, which is just a regular radius, a conic, curvature, which we had before, and control the magnitude or the the intensity. This is a little bit sharper. Look at that, like that, or the other direction to make it kind of flatter. In fact, we can take it all the way to a chamfer, which is what this option is here. And that chamfer is obviously a linear blend between these two faces. They can be asymmetric. I can make a chamfer that's 9 and 7 on its 2 dimensions here, or 6 and 9. This, as I probably said in other videos, the face blending toolkit is extremely deep and broad. So I encourage people to play with that somewhat.